Assalamu alaikum dear student. This is our third video in chapter number 6, Plane Analytic Geometry, exercise 6.1. In the end of the second video, we have solved question number 6. Now we come to question number 5. This question is about isosceles triangle. Dear student, you first know the definition of an isosceles triangle. It is that triangle whose two sides are equal in length. Suppose that we have a triangle A, B, and C. If we find all the three sides of the triangle, and out of these three, two sides are equal in length, such a triangle is called an isosceles triangle. Now we come to the question. This question is given in my notes. This here. A, B, and C are three vertices, 3 points, and we have to show that these 3 points are the vertices of an isosceles triangle. Dear students, you are familiar with the concept of the distance formula and the use of the distance formula. You can use distance formula to find AB distance. Here in this case it is square root of 5. BC distance, which is again square root of 5, and CA or AC distance, which is equal to square root of 10. We have calculated all the three sides of the triangle. Here we are observing that the two sides of the triangle are equal in length, and hence this triangle is an isosceles triangle. Now we come to question number 7. Dear students, in question number 7, we have to find an unknown point Pxy, but a condition is given that this unknown point is equidistant from three given points A, B, and C. That is, here the distance PA is equal to distance PB is equal to distance PC. This is the condition of the question, and on the basis of this condition, we have to find this unknown point P. Now we come to this question. Here is the question. In the question it is said that find the point, unknown point, which is equidistant from the points A, B, and C. Suppose that the unknown point is Pxy. Students, first we are calculating the distance PA, PB, and PC by using the distance formula. Here is PA distance, here is PB distance, and here is PC distance. Now, as the condition of the question is given, in the condition it is said that PA distance is equal to PB distance. This is PA distance and this is PB distance. We have used distance formula to calculate this. Now we have to calculate the value of x and y. For this we have to simplify this relation. Now I'm squaring both sides. Squaring both sides, we get this one. This can be expanded by using a minus b whole square formula, and this can be expanded by using a plus b whole square. Thus we can expand all these four squares by using either a plus b whole square or using a minus b whole square formulas. Now after some simplification, we get 3x minus y plus 5 is equal to 0, and it is marked as the first equation. Now again I am using the condition that PB distance is equal to PC distance, because in the statement of the question it is clear that all the three lengths PA, PB, and PC are equal. Now PB distance is equal to this one and PC distance is equal to this one. This is by distance formula. Now squaring both sides, the square roots are eliminated, and after certain simplification we get this relation x minus y plus 9 is equal to 0. We have marked this the second equation. Now we have to solve equation 1 and 2 in order to find x and y. In this question I have subtracted equation number 2 from equation number 1. And this subtraction produces 2x minus 4 is equal to 0, from which we get x is equal to 2. Now to find the value of y, we have to put the value of x either in equation number 1 or in equation number 2. Here I have used equation number 2. Now putting the value of x, which is 2, in equation number 1, we have 6x minus y plus 5 is equal to 0. And after certain simplifications, we get y is equal to 11. Here x is 2 and y is 11. X and y are the coordinates of the unknown point. So the unknown point Pxy is equal to P211. Thus P211 is the point which is equidistant from point A, from point B, and from point C. Now, dear students, we come to another concept which is called the ratio formula. I'm going to prove this formula. Here is a simple way of the proof of this formula. The ratio formula is so that suppose we have 2 points A and B, and there is a point C lying somewhere between A and B such that C is dividing the line segment AB in 2 parts, one of which has length P and the other of which has length Q. And in this formula, we will calculate the coordinates of this unknown point C. In other words, where this point C lies inside AB. This is our target. The statement of the question says that the coordinates of the point CXY that divides AB in ratio P and Q are the coordinate of the unknown point here CXY. Cx can be calculated with the help of this formula and y can be calculated with the help of this relation. Now we come to the proof of this formula. From the figure we observe that A and B are 2 given points and C is an unknown point which lies inside AB somewhere, whose coordinates we are going to calculate. First we draw a perpendicular from point First we draw a perpendicular from point A on the x-axis, and it is the x-coordinate of the point. We draw a perpendicular from the point B on x-axis, which is the x-coordinate of the point B, and we draw a perpendicular from point C on the x-axis, which is the coordinate of the point C. X is the unknown value. Dear students, we have observed that the distance from x1 to x2 can be calculated by subtracting the initial from the final. So this distance is x minus x1, and this distance is equal to x2 minus x, the difference between x and x2. Now, dear students, observe the figure and apply the elementary geometry. The ratio of P and Q, the ratio of P and Q is P divided by Q, is equal to the ratio of their corresponding images. The image of P is x minus x1 and the image of Q is x2 minus x1. So the ratio of P and Q is equal to the ratio of their images. Now we are cross multiplying. P is multiplied with this one and Q is multiplied with that one. P is multiplied with these two and Q is multiplied with these two values. Now after arrangement, we have Qx plus Px is equal to Px2 plus Qx1. We are taking x common. We have P plus Q, and this is same. As we are interested in x, we are shifting P and Q to the right side. We have the value of x. On similarity basis, we can find the value of y by replacing x1 by y1 and x2 by x2. Here is the x coordinate, and we are going to find with the help of this the y coordinate. So the x1 is replaced by y1 and x2 is replaced by y2. Hence, x coordinate is equal to this one and the y coordinate is equal to this one, and this is the proof of the ratio formula. Dear students, in this proof the point C is lying inside AB, but it is not necessary that always the point C lies inside AB. It may lies outside AB. When it is lying inside AB, we call it the case of internally, and when it lies outside AB, it is called the case of externally. Now, what is the difference between the two cases? The second case, the case of externally, can easily be derived. Dear students, you observe that the direction of AB is this one. This is the direction of AB. We observe that AC distance which we have marked P and CB distance which we have marked Q, both are in the direction of AB. Observe that AC is in the direction of AB and CB is also in the direction of AB. So both P and Q are taken positive. But in the case of externally, we observe that the direction of AB is this one. Here AC is this one. This is AC. It is in the direction of AB, but CB is in this direction, which is the opposite direction of AB. Since in this case CB is in the opposite direction of AB, so the length of CB is marked negative. So it is minus q. We have observed that in case of the internally, P and Q are both positive, and here both P and Q are positive. But in case of the externally, P is positive, Q is negative. So if we replace the positive Q by negative Q, the case of internally converts to the case of externally. So for the case when C is lying externally, we are replacing Q by minus Q. Here if we replace Q in both the places by minus Q, we get the x coordinate of the point C when it is lying outside. And if we replace both Q of the y coordinates by negative Q, we get the y coordinate of the point C when it is lying externally. Hence replacing Q by minus Q, we get the case of externally. That is the case when C is lying outside AB. This is the ratio formula. Dear students, the point C, which we have discussed in this either externally or internally, if this point C is lying in the mid of line segment AB, yes, in this case, C is lying in the mid of AB, that is C is dividing AB into equal parts. AC is equal to CB. When AC is equal to CB, you observe that AC is P and CB is Q. When we say that AC is equal to CB, it shows that P is equal to Q. So if C is the midpoint, then we say that P is equal to Q. And when C is the midpoint, we call this midpoint formula. Dear students, from the ratio formula, we have observed that this is the x coordinate of point C and this is the y coordinate of point C. But in case when C is the midpoint, we have that P is equal to Q. So we can replace P by Q or Q by P. In this proof, I have replaced Q by P. So replacing Q by P in this relation, we have this one, and replacing Q by P in this relation, we have this one. Taking P common, we have x1 plus x2 divided by P plus P is 2P. And taking P common, we have y1 plus y2 and P plus P is equal to 2P. P is cancelled out with P is cancelled out with P. And hence we have x coordinate x1 plus x2 by 2 and y coordinate is y1 plus y2 divided by 2. Dear student, from here we observe that if C is the midpoint of line segment AB, then x is the average of x coordinate and y is the average of y coordinates. Thus we can say that in case when C is the midpoint, the x coordinate of the midpoint is the average of the x coordinates of the ending points of the line segment, and the y coordinate of the midpoint is the average of the y coordinates of the ending points of the line segment. And this is the end of our third video. Goodbye. Khuda Hafiz.